Good afternoon and welcome. My name is David Libesman. I am the VP of Data Analytics at iPipeline, and I am responsible for the ongoing strategy and delivery of iPipeline's enterprise data analytics and data science practice. I've been working in the industry for about 30 plus years, and working in the data cloud has been a game changer for myself personally, as well as for what we have been able to achieve at iPipeline.
Hi, my name is Tom Hagan. I am a data systems manager at iPipeline, and today I will be speaking about a few of iPipeline's use cases and doing some technical demos of our solutions built with Snowflake and Sigma.
We are super excited here to present to you how iPipeline is leveraging Snowflake and Sigma to enable data sharing and self-service analytics. We are going to cover today a quick overview of what iPipeline sees from a data perspective, the solutions that we have delivered, both from an embedded analytics perspective and an embedded self-service perspective. And then we are going to do some deep dive with one of my colleagues, Tom Hagan, who is going to take you through a number of use cases that we have deployed. iPipeline is a leading provider of cloud-based software solutions for the financial services industry. We've been around since 1995. We have protected over 25 million lives, seen billions of premium flow through our system, and millions of applications and quoting occurring throughout the lifespan of the company. iPipeline's marketplace includes a vast connected network of carriers and distribution partners supporting agents and advisors in the sales and service of financial products, specifically life insurance and annuities. Our platforms support the digital process from quote to enforce, and we see millions and millions of transactions across the network, which provides us a very rich benchmark set of data. iPipeline's InsureSight embedded and self-service platform is powered by Snowflake to support a single source of truth of all the data flowing through all of our various different applications. We offer the best of both worlds. We offer the better capability through traditional dashboards for customers to access their data, and both their data as well as benchmark data. And in addition to that, we also offer customers the capability to self-serve their data in an extremely powerful self-service platform, leveraging Sigma directly against Snowflake in a data cloud architecture. iPipeline's embedded analytics provides significant value to our customers through a traditional BI tool, where those customers can access that data via secure login to pre-canned dashboards that provide them insight to their own business, as well as insight to benchmark data. This platform provides daily refreshes of data. There's no code required. There's no data team needed, and there's industry-tested analytics. There's tons of value delivered through that platform, but that's not enough for our customers. So what we have done in addition to that, we have delivered to them now a self-service platform that is powered by Sigma that provides our customers the capability to not only access the data via the gateway in a secure way, but also provide the ability for us to deliver data to our customers via a secure mechanism through pushing data to an Amazon S3 bucket, as well as providing access to customers all the way back through Sigma and using the powerful Excel-like interface, and then all the way back into Snowflake through data sharing. This has provided significant value to our customers so they can actually go in, access that information, and not having to rely on anything from iPipeline other than access to the data through a secure mechanism. All this is powered by Snowflake and Sigma. It's giving you access to real-time data, multiple data integration options. It's very customizable, and it's completely self-service. It allows customers to get a full 360-degree view of their business, and no question can not be answered by the data that's available through this platform. We are now going to dive into a number of use cases and why they actually came into existence. All of these use cases are powered by Snowflake and Sigma. First use case was driven by customers requiring access to their data that's been collected through our system, and they wanted to integrate that into their portals as well as their CRM systems. Second use case was the ability for customers to interrogate that data through our portal, but be able to customize their own reports and create their own slices and dices of data and create their own analytics. Third use case was driven by the fact that the customers had 300 to 400 column reports on very large data sets, and that became impossible for us to deliver through a traditional BI tool. And the last use case was customers really wanting to get access to the data, but they wanted us to push that information to them through a mechanism where they would be able to pick that up and integrate that into their downline systems. And we have leveraged Snowflake and Sigma to use the scheduling, powerful scheduling capability to push that data into a S3 environment in AWS for our customers to get access. Now I'm going to hand over to Tom Hagan, who will be able to take you through all of these use cases in a much more detailed technical level.
At iPipeline, we have a lot of customers set up with Snowflake secure data shares. We've recently sunset a homegrown Dynamics CRM product. So we're helping our customers transition from our product onto their own custom solution that they're building in-house. So to enable that, we set up a Snowflake data share, and then we work with our customers and we walk them through setting up the correct driver based on the language of the product that they're creating. Or if they are just interested in getting the existing CRM data that they have, we will set them up with self-service in our Sigma embedded product in our InsureSite platform, and which is especially good for some of our agency users who might not have their own data teams or might not have their own technical staff that could create a full-blown custom product to replace the existing CRM product. I'm going to walk through a few of the different pieces that enable the InsureSite cloud data platform and translation platform at iPipeline. All of our AWS infrastructure is managed in Terraform, and our Snowflake staging deployments are managed by homegrown Python utilities. And here I'll walk through from source to Snowflake what gets deployed. You can see on my screen we have AWS console open showing some of our database migration services tasks. So for each source database that we're trying to consume into our Snowflake data platform, we have a DMS replication instance set up and one or more DMS tasks set up. If I take a look at one of the individual tasks, we add a few mapping rules so that we can include some extra metadata information that will help us maintain an accurate historic chain for each partition key in the source data. So you can see we add a commit timestamp, and we're adding the stream position as it's coming through DMS. So the destination for these DMS tasks are sent to Kinesis delivery streams. And there's nothing really fancy going on here except that we are defining the S3 bucket destination and then an S3 bucket prefix. So in our Terraform, we have, an individual customer or product defined where we can dynamically fill out all of the bucket prefixes and the S3 destinations so we can rapidly deploy new products or customers. If I continue down the stream, we can see this S3 bucket location with our source database folder and the JSON prefix that we had defined in the Kinesis delivery stream. And then Kinesis will partition the dates into their folders. So we have October 20th, and then in near real time, these folders are getting created by Kinesis. So if I click into the transactions that have happened today, we can see the gzipped compressed files that get dropped in S3 for every operation that happens in the source database. So we're capturing all of the CDC records in near real time as they're happening at the source. If I open up one of these compressed files, we can see the actual CDC format of the records that are getting dropped in S3. We can see the metadata that we added in the DMS task for the stream position and the commit timestamp and some other extra metadata that's useful that we'll be using downstream in Snowflake. So we can see like the table name, the partition key from the source table, and then actually what kind of CDC operation it is, which will be helpful when you're determining if it's the most recent version of the record or if it falls into the historic record bucket. And then for each of these CDC records, we see the actual data object, which has, one-to-one relationship with the source tables columns and the actual data that we're looking for in S3 when it comes through. So if I flip back to Snowflake, we set up a Snowpipe and a storage integration with permissions for Snowflake to go back to that bucket and pull in any new CDC records that come in based on this storage integration definition. So we have the S3 bucket location, we have the external ID, user and role ARNs for Snowflake. And then part of our Terraform deployment, we have the role that's set up for Snowflake. And if we look in the trust relationship, it has that external ID and the ARN for the role. And then the pipe definition is pretty straightforward. We just have a copy into the JSON load table, just looking at any new records that come from the SQS queue. So as they're landing in S3, the Snowpipe will pick up all of the new gzip files from that S3 bucket location and bring them into the JSON load table. When we first initialize these things, we'll do an initial run that just does a copy into any of the records in the S3 bucket. So we kind of have an idea of what metadata we need to look for when we're trying to recreate the source tables as views in Snowflake. So you'll see we have some of these views that are sitting on top of this JSON load table and pulling out just the metadata information about the tables at the source. So part of our deployment, we also have to deploy a task. And so we can tell the difference between the most current version of a record and whether or not it's a current or historic record. And we do that through this task that just calls a procedure, the continuous history load, which just runs every night around midnight. And what it'll do is go through the JSON load table and dynamically run in batches any JSON load records that don't have that first known record or last known record or start and end timestamps. So after that job processes, these columns get recalculated based on what the CDC operation is, based on the data lake start time, end times. It'll update each of these records with the is first known record and is last known record. So another critical part of our deployment is managed from a Python utility. And for each of our product definitions, we will define an ODS object, which is basically that JSON load table and all of the metadata that we've collected in those views about what the tables and columns look like at the source. So once we have our ODS defined, we can use just a Python utility script that we created in-house that just takes a couple of arguments about what that JSON load database looks like. So for instance, the one I'm showing in this example has all of the CDC operations in JSON format. So if I run this script for the ODS we have defined, this will take a minute to run. Ultimately, it'll spit out this build directory, which will kind of package together all of the SQL that we need to deploy our Snowflake objects. And then we can see in our manifest file, it'll go through, and when I actually use our deployment utility, I can define the build. I just punch in this build ID. And what this will do is just run through our manifest. It'll create the ODS metadata views. If we have any history related tasks, it'll deploy those. And then this is just versioning, which is version control for our internal purposes. So after we run a build for our platform staging database, in addition to that JSON load table, we'll have the original annuity order staging, and then we'll have our ODS staging, which uses the metadata from those views to recreate the tables from the source as views in Snowflake. So after the pipe is created and the ODS staging objects are deployed, we have all of the database objects that support near real-time analytics and provide a complete chain of all historic transactions that have happened in our source databases. In our existing InsureSite platform product, we use Sigma application embedding to offer self-service functionality to our data factory users. And we call this Sigma Lite in the embedded version because our customers can piggyback off of our account for the not so technical users. Maybe they don't have a data team. So we allow them to do self-service through our portal. That way there's no vendor agreement, there's no IT or security reviews. We do create a connection from our Sigma to their Snowflake instance via private link. We help them get set up so there's secure communication between our Sigma tenant and their Snowflake tenant. There are some drawbacks to using Sigma Lite. For instance, users aren't able to materialize their data sets. They're not able to connect to other data sources, but they can do all the customized reporting for kind of the curated data that we've made available to them through that embedded experience. We kind of use that as the line in the sand where if you start requiring data set materialization or you start requiring more customized data inside of your solution, then we'll push them towards a full Sigma implementation where they have their own account versus using ours. So once we use our deployment utility, we have a customer database that has curated content or ODS source table content that is specific to that customer. So depending on what iPipeline products, they will have all of the data from their source systems available to them in Snowflake. We can set up a data share from that data, or we can create a connection in Sigma with the permissions set up so that they can self-serve on top of that database content. Something we've done in our partnership with Sigma is create an embedded version of Sigma that's made available through what we call our application gateway. Our application gateway is protected by ping. So in the Sigma embedded solution, we use ping to control user and group management. What we've done in the application gateway is to pull the groups out of the ping response header. So what we might have is something like this from the ping response, and we're using this user groups attribute, and then based on the groups that we've included that user in, all of them need to include the string Sigma. So we have two here for this test user called Sigma US All Customers and Sigma Testing Customer. The provisioning in the Sigma embedded solution will pull these groups out of the ping header and then try to add that user to the corresponding group that's named exactly the same in Sigma. So when the embed URL gets generated, it'll pull out those groups and look for the exact groups in Sigma. So you can see we have the Sigma testing customer, Sigma US, all pipeline customers. So if I look in this UA2 group, I have my embed user and the email address that I use to log in. So when I look in our application gateway, again, based on those ping user groups, if this user is a member of our self-service through Sigma group, they'll have this option in their menu for self-service. When they click that menu item, we'll see there is an iframe that gets generated in the application gateway. And if I look for that iframe element, I can see it's just the iframe and it has the embed URL from Sigma that is just the embed ID. So it's really just dropping your embed URL in an iframe, and then you get the whole Sigma experience in a custom web application. So based on what ping groups the user's in, they'll have access to one or more workspaces, and then they're able to self-serve, slice and dice, and create their own content directly in Sigma. Using Sigma and InsureSight's Data Factory in Snowflake, we give some of our financial institutions easy access to compliance reporting. Using Sigma, we can give our customers very wide 300 to 400 column reports where customers can have access to all of the underlying audit data that they need and drag and drop, rename anything that will help them fulfill their audit requirements. We tried this report deployment using other traditional BI vendors, and it just wouldn't work. The workload of a 400 column report was too much. We ran into rendering issues from the web applications. We ran into just query performance issues. Returning the view logic for a 400 column report is pretty intense. So when we use Sigma to create these wide column reports, what was really critical for us was Sigma's use of materialization. So we had a data set that we could set up for materialization on a nightly schedule on a small or medium warehouse, and it would run in the middle of the night for a few minutes. So the next day when our customers would log in, they would have fast reads from the materialized data sets. So doing all of their self-service auditing was really went from a big pain of ours to a really elegant solution using Sigma. Another critical use case for iPipeline using Sigma is the ability to consolidate all of the custom report delivery processes that our product teams manage and create a single managed and automated process in Sigma. Our professional services teams offer custom reports as a value add to make our customers more successful in their daily operations. As such, they managed and created multiple different delivery methods, but with our new cloud integration solution using Sigma, we can not only decommission our existing delivery means, but internal teams are no longer responsible for exporting and delivering reports securely to customers on a regular basis. So now with the cloud storage integration, this is now completely automated, customizable for each customer implementation, and managed 100% in Sigma. Here we have the Sigma to S3 cloud storage integration, and what I have up now is an example of a custom report that we might create for our customers. Using the scheduling feature in Sigma, we can set up a scheduled export to use cloud storage. So I have one set up here using a storage integration object that we create in Snowflake. We can set up the permissions necessary for Snowflake to drop files into an S3 bucket location that we define here. So we use this checkbox to prefix the file name with the current date so we don't overwrite those files, and then we set up this schedule to deliver once a day, every day at 9 a.m. So this allows us to set up custom reports and their schedules to get delivered regularly to our customers. After I save this schedule, it'll run regularly every day at 9 a.m. And then if I flip over to S3, we can see the prefixed file name included with the actual name that we defined in the schedule, and then it's getting delivered every day around 9 a.m. So this is the process we will use to replace all of the professional services teams and have them all delivered via cloud storage integrations in Sigma.
Thank you very much for attending the session today. We hope you found this session insightful and informative, and we are hopeful that you can take this information back to your own organizations and look at how you can deploy the same successes that we've had leveraging Snowflake and Sigma to deliver both an embeddable solution and potentially an enterprise solution and solving these kind of use cases that we've been able to educate you on today. Thank you very much.
Snowball fight! Wow! You really stepped up your game! I've been using Snowpark, silly. It lets you build snowballs with confidence by removing data security and compliance barriers to production with consistent enterprise-grade governance controls. Pretty cool, right? Wait, what? Frosty gets his own song. Why aren't we singing about Snowpark? The easy way to production for Python. Using pre-installed packages and automated dependency management and secure processing. How do we make that rhyme? Oh yeah, speed! Woo! I built this myself. Nothing could go wrong. Oh no! Ah! You didn't use Snowflake Snowpark. It's the only way to go. Woohoo! I'm going so much further. Eat my